What up?
Yo, what's up, man?
What up?
All right, so yeah,
Okay,
I'm
so
waiting.
okay, so let's make it very absolutely clear. You were saying
Hmm.
that the apparent horizon, the horizon that we observe, is a physical place.
I'm saying the apparent horizon, the horizon we see due to refraction or a lack of refraction,
Hmm.
and when there's a lack of refraction, it's more likely that your apparent horizon becomes your geometric horizon. I'm saying that is a physical location in space-time.
Okay, now let
Yeah.
me explain how it's not. Okay,
Okay.
due to the refraction, due to the atmospheric conditions, you are not getting the, we'll say, actual horizon. This is how we know this.
Yes.
We call it the apparent horizon because if you're standing in one location and I'm standing in another location, we do not have the same horizon. We have our own horizon, which makes it the apparent horizon, correct?
Yes.
Okay. Now, there is a twist in this explanation because there is a physical location of the horizon. Here's a problem, and I was making it clear. The only place that this does exist is the geometric horizon.
I
Here's
totally
a
agree with
problem.
that.
Okay. The reason why I can say with confidence that the apparent horizon is not a physical location is because the geometric horizon, though it will never say in words it's a physical place, the geometric horizon is the only place where you would have a fixed location of a horizon. The reason you will have this is because the geometric horizon is also used in a non-real world situation, kind of like testing gravity in a chamber. Take out all the atmospheric effects, you take out the refraction, you take out the conditions, then you can have
Mm-hmm.
a geometric horizon. But because we do not observe a geometric horizon, we observe an
Mm-hmm.
apparent horizon, making it no longer physical. If you are on at we're at that classic 6 feet, and the horizon is 3.5 miles away. You go 3.5 miles an hour, 5 miles away. Your horizon is not there. Your horizon is another three whatever miles away, depending on your height. But you're not at your horizon. The horizon will physically move with you, which makes it your horizon. If you put a building at 3.5 miles off the beach and you said, and it was at the horizon, at your apparent horizon, you can go to that building because that building is a physical object. That is a fixed location. That building does not move. See how it's different? See how the explanation of it is? It is a very worded explanation that you have to be careful for. And I only jumped on you because it is something that a flat earther will jump on you for. Why? Because I did.
Okay.
It wasn't. I'm not saying you're wrong. It's just it's. You said physical. You were saying physical like Montreal did, and I went through this with Travis so much that I literally went through every route ins and out of research about the horizon. And this is one point that I feel like I can confidently give a great explanation for. Um, it's literally just the remembrance of the geometric horizon does have a fixed location depending on your altitude, but then again, it's not real world. The apparent horizon is our real world horizon, which is why it's not physical when we talk apparent.
Okay. So I tend to agree with 90% of what you said. Our geometric horizon is never really the same as our parent horizon. Our parent horizon moves when you move, and
Mm-hmm.
that's all fine and dandy, but that doesn't make it not a physical spot. If I look out at
Yes.
my parent horizon, I can put a marker at that
Mm-hmm.
specific location in space time
Mm-hmm.
where the water
Yep.
and the sky meet.
Yep.
I can put a physical marker there and walk
Okay.
to it.
When you
Obviously, as I
walk,
walk to it,
yep.
my horizon changes.
Yep.
But
Therefore,
that marker
your marker is
is
not
still
on the
within the physical location within space
no,
time. It is
no, no,
physical.
no, no.
No. Why not?
Yes, the marker, yes, is a physical location. The problem is your marker no longer is a physical location of a horizon. Your marker is a physical location of where you marked something. It's not a physical location. Just like I said this, if there was a building, AE, that marker, you could go to that. That marker is physical. The horizon, which moves with you, is not. You put a marker, and this is another reason why it's not a physical location. If you're standing in one spot and the building or your marker or your horizon is what you're observing, if I'm standing at another location, your marker is not the horizon. Your marker is your horizon, making it still apparent, still not a physical location. Because if it was physical, we would say, I see your marker, you say, I see your marker, and it is at the same location. That's a physical location. The horizon is not, my friend. I just mind fucked, didn't I?
No, I'm not mind fuck. It's just,
but no,
I think.
Do you understand what I'm saying? It's a very, you using the marker gives it a better explanation for how it's not physical. The marker is physical. For me, for you, that marker is in a location, a fixed location. That location,
a fixed physical location in space time.
Yep, that marker.
All of your horizons move with
listen.
you.
But listen, for you, your marker is in a spot, right? It's marking your apparent horizon.
Physical location in space time where my horizon is.
It's marking your apparent horizon, correct?
Yes, which is a physical location in space time.
Okay, hey, hang on. Now, if I'm now 5 or 3 miles up the beach and I can see your marker, is your marker in the location you see it at?
No, we would see this marker in 2 separate locations, but it's still a physical location.
No,
yes,
we would both see.
If I put a marker on the horizon and we are standing at different places, we would see this marker in a different location. It's like seeing a ship on the horizon.
Stop. Hang on.
Yeah, so we would look in the same direction and see the same ship.
Yeah. Hang on. So you're telling me this?
Yeah.
You're telling me that if you put a marker 3 miles out, and I'm 3 miles away from you up the beach, we wouldn't see that marker at the same location. That marker would we
would see that marker in the same spot, in the same physical location in space time. But it is not the same distance from either of us. Number one,
100%. You're right.
Yeah.
You're right. Okay. Now hang on. So we've established that the marker is in its spot. We both see that marker where that marker is. Even though
the physical location in space,
even though the distance is different. Now,
what's the argument if we agree that this marker?
Yep. Now here it is. Because that marker is marking your apparent horizon. Guess what? It's not marking for me. It's not marking my apparent horizon, which means your apparent horizon is not a physical location.
It is a physical location.
It's okay. If we're not talking about the horizon and we're talking about your marker, that's a physical location because that marker is in the same location for both of us. But the horizon is not in the same location for both of us, making it not a physical location.
So you're saying, all right, it sounds like the crux of this argument is you feel something can only be physical if it is in the same location for 2 different observers. That's your argument in a nutshell.
It's not a physical location because
but I mean we agree that is your argument that if you and I are in 2 different locations looking at the horizon, because the horizon is not the same for both of us, it's not physical.
Exactly.
That's not true, man. That's not true at all.
It's 100%.
It doesn't matter whether the horizon is apparent or the geometric horizon. We would never have the same horizon. Even if there was no refraction, our horizons wouldn't necessarily be the same.
Wrong again.
No, that's the truth.
Here's how it works. The geometric horizon is the mathematical equation for what you see without atmospheric conditions.
Refraction, yes. But that still changes based on your position.
Yeah, you're only your altitude, not your distance, only your altitude. Now, for your apparent horizon, it changes.
No, that's not true. Because if I am close, if we put a marker at the actual horizon, right? Not the apparent one, and I'm closer to that marker than you are. I would still see further out.
Are
That
you
marker would not be my horizon.
Are you talking geometric or are you talking
Geometric,
apparent?
yes.
Okay.
The
If we're talking
geometric
geom- okay,
horizon
if
is
we're
based on
talking-
your location, right? If
based
we
on
are in
your
separate
altitude,
locations,
based on your altitude.
altitude and where I am on the ground.
Altitude.
If we are
yeah,
at different
altitude.
locations, we would not have the same geometric horizon, Sean.
No, you're
You
right.
can
exactly.
you can. It's like
You're
it's
right.
like using the curve calculator
exactly.
and
No.
not factoring
listen,
in refraction.
You're
It's
right.
the exact same thing happening.
You want to know why? You want to know why? Because the geometric horizon isn't real world. So it's not going to establish. It's not going to establish a.
It's not real world. What does that mean?
It's when we observe something, and if you use the geometric horizon, you're not going to have. You're not going to. It's not going to be accurate because it's not counting refraction. It's not counting weather. So when you say when you sit there and say it's the geometric horizon changes, yes, you're right, because the only thing you can use the geometric horizon for is to find the geometric horizon in your one location, your one altitude, not a bunch of different locations, because it's not physical. Again, if you put a building or your marker out there, you're always going to be able to pinpoint where that marker is because it does not change its location. The geometric horizon is non-real world, therefore it is not what we observe. It is literally a blueprint. A blueprint does not factor in problems. A blueprint does not factor in redos or changes like refraction or weather. Again, you're describing a physical location or a fixed location in the wrong sense of our observation. You're talking geometric. Even in geometric, it's still not a fixed location because that fixed location still does change. A building or a marker would not change its location. It would only change your view of that location.
I totally agree. But that building or whatever is still in a fixed location within space-time at your horizon.
Yep.
Yes, your horizon changes
and no matter
based where.
Yep.
No,
exactly.
But, okay, Sean, you got to let me speak as well, man. You really got to let me talk as well.
100% right. I'm sorry. Go ahead.
Yeah.
I'm sorry.
So the crux of the argument is you feel because our horizon is ever moving, whether there is refraction or there isn't refraction, both horizons move based on your, latitude, longitude, altitude, attitude. It doesn't matter. These all change your the distance or the point at where the floor meets the sky. That's fine, but that is still a physical location. Just because it moves when you move doesn't all of a sudden make it non-physical.
Yes, it does.
Right.
Sorry, it does. Okay,
we are going to never agree, and you are going to have to maybe define what you mean by physical.
Okay.
And
you ready?
Yeah.
A physical object is an object that is in its fixed location at a certain point.
Okay. A physical object is an object that is in its fixed location at a certain point.
Yes. So for every
point
in space time, it is at a fixed location, a physical object.
Okay. So why would our horizon not be at a specific point in space time?
Because
it occupies space and space time. It's light. It's light refracting what we see at a physical time and location in space time.
Okay, so
it moves when we move. That's fine, but it has a physical location.
Okay, so when we see miraging, for instance, mirroring or looming, is the miraging physical?
The miraging is causing a physical item to be distorted. Yes, everything we see is a mirage.
That's not what I. Okay.
As long as you are within Earth, within an atmosphere, within an ever-changing medium, everything we see is a mirage.
Yeah. Okay, but
But we still measure the physical locations of these things being mirage.
If we see a boat, and the boat is refracting and inferior miraging, so it's mirroring. Is the mirroring aspect of our observation physical? Or is it optical?
It's both, man. The
So
mirroring
there's
is being caused by optics, but it is a physical thing being mirrored. We can still measure that physical thing's
no
location.
the
Yes.
physical object that is that. So the boat in this instance, it is a physical object that is
Hmm.
mirroring. The mirroring is an optic is a optic
An
and
optical
with
effect,
is
yes.
an optical effect of the physical object, but it is not
Okay.
physical of itself. The same way that it works the same way with the horizon. You see the horizon, but it's not the horizon because it's if you move 10 feet the other way, it changes very slightly, but it does change. It's not a physical location. It's not a spot that will not move.
Okay, cool. Let me ask you this. If there is a house in the distance, right, on
Yep.
Earth, within
Yep.
our atmosphere,
Okay.
because it is within our atmosphere, the
Mm-hmm.
light moving in between us and that house
Mm-hmm.
is affected by refraction, by
Yep.
distortion, by
Yep.
everything because of the
Yep.
atmosphere. But I can
Yep.
still measure that house's physical location. Now, when I measure
Mm,
that house's
within how
physical
much?
location,
Okay. What would you say the
when
accuracy of that location would be?
I don't know, I would say 100% accurate because I could measure it and walk to the house. I could draw a map to
Whoa.
that house,
Okay.
even
Wait.
though
Wait.
it's
Okay.
being
Yeah.
refracted.
Okay. But
Couldn't I?
if you're doing it with just your observation and optics, and you have refraction involving it, you
But we
would need.
always have refraction, Sean. When
Oh
you're
yeah.
looking
Yeah.
at your
Yeah. Yeah.
PC,
Uh
there's
huh. Yep.
refraction happening, right?
Exactly. Which is why
But
the
you can still
geometric.
put
Yeah.
your hand out and touch your computer
Okay.
screen,
Okay.
even though
Oh, there's not enough refraction for that. But like you're saying, because what you did say
yeah,
is
it's
a
still
good
happening.
example. So if we
Hmm.
look at a house in the distance and we can tell if there's refraction involved in our observation, and you try to use you try to use you try to use geometry without taking out or without including the index of refraction, your location is not going to be 100% accurate. It's going to be
Okay,
within, I'd say
if
within
you're
60%.
if you're making that claim, let's actually test it, Sean. Let's do the mathematics. I'm down for it. Do you want
Okay,
to do the math right now?
we could.
I think that's
Absolutely.
the only way we would ever prove who's right or who's wrong. So let's say we're trying to figure out the location of something 5 miles away,
Hmm.
and let's set our parameters, right? Our atmospheric conditions, our altitude, our attitude, our longitude, and our latitudes.
Do
Right.
you really think that's, wait, do you really think that's absolutely necessary?
Well, if you're making a claim, you made the claim, right? That if we did the
100%.
math, it wouldn't be accurate.
Okay,
So I mean,
so
it's
then
the only
here's the
way
problem. Okay,
we're
here's
not
the
going to
thing
argue
then.
anymore.
Okay, here's the problem. Then at that point, we need an observation that has known refraction. We have the known distance, temperature, and all the data that we would
Yes.
need to.
Yes.
So we can't make this
Yeah.
up. We need an
Why
observation that
not?
actually does it. Because to make it up, you're then okay. If that was the case, you wait. Better yet, you understand what you want to do. A.e. make up a situation
Yes.
is literally making a fantasy situation, which the numbers are extrapolated through this. I don't even know how to. It only makes sense to use it on an observation, but better than that, it doesn't make sense to me that you're so persistent on this being a horizon being a fixed location, even though it's already been explained that a fixed location is a physical body. The horizon isn't physical because if it was physical, you would be able to reach that point and be at it, like your marker. Your marker doesn't stay at the horizon. As you walk closer to that marker, the horizon doesn't stay there until you get there. It moves. You're marking a apparent location, not a physical location. That is the whole crux of it all. It's an apparent horizon because the definition of apparent is it's not a fixed location.
Yeah. I think that's where we're going to disagree unless we actually do some mathematics and modeling, Sean.
Or
Because just
without
talking, we can throw out terms and or maybe if you have an observation that we could run through. I don't know. Do you have an old photo? Something, man. Because I think just talking, we're not going to get anywhere. Because I'm 100% sure if we did the math, you would see what I'm saying. I've done the math. You know, this is the stuff I studied. I studied
Okay.
optics.
Okay,
I,
well, then
I
how
can
about
tell
this?
you.
Okay, and that's
Uh-huh.
it. Since that's you understand that so much to that point, then you make up the situation and explain to me how you come to the conclusion that it is a physical location.
Okay. Um, let's say I'm looking. All right, let me pull out a curve calculator, something where we can just input the stuff and the figures come out for us. Do you have one? Like a good site you use? Yeah, if you could pull one. Something where we could both input the figures and it would make it simpler for both of us. Because I don't really want to pull out a piece of paper and a pen right now.
I know I have one. I got to figure out which my bookmarks. Calculate. I know there's a good one. Oh, there it is.
Hang on, Sean. I'm gonna leave this Google thing, man, because you guys are so loud. Okay.
Yeah.
Damn, those guys are loud.
I'll share the link in chat that I'm using. It's the Walter Bisbee one, because I know you can put all the numbers. And we can go through it step by step if you want.
Sorry, just hang on.
And on this one, also turn refraction off too. Yep.
All right.
Refraction.
Let me see. Yeah.
So we can.
This looks pretty good. Okay. So what we want to do is we want to say. I even forgot now what it is we're trying to prove. So we want to say if we do this calculation with refraction,
should give us that they won't have the same locations.
With or without? Oh no, but I mean, I
remember the geometric horizon and the apparent horizon, because they're ones with and without refraction. You said that it's a physical location, which means it would have the same location, and you said you could pinpoint the location, the house, even with refraction.
Yeah.
So that means without refraction, it's going to give you the same location. That's not true because it's not a physical.
No. That is not what that means. It means I can pinpoint the location with or without. So with refraction, I can pinpoint its location. Without refraction, I can pinpoint its location. But if I was to walk to that location with or without refraction, I would end up at the same spot.
Okay,
that's
so
my point.
Before we punch in anything, then we need to have the same refraction number on there before we put anything in there. So you don't have a non-refraction number.
Okay, I'm putting all the sliders down to 0 first.
How about we do this? I'm going to keep my refraction at 0, but all the other numbers will keep the same, and we'll see if we come up with the same number. Is that better?
Okay. Good deal. Cool. So you keep your refraction at 0. Yeah. I'll have my refraction at what? At 1. Yeah. And then, all right. What is our observer height going to
be? Hey! Remember, this is your thing. Remember, you studied, you did it. So This is.
Let's say 10. This is meters. 10 meters. Okay. But it's so. I can type it in, right?
Yeah.
Because the slider, it's a bit difficult to get it right to 10. Yeah. 10 meters, target distance 10, target size, what, 10? Otherwise, it's not, 100.
Target size.
How come 100? I can't see it? Okay, so it's not coming into view. It's fine. Refraction, mine is at 1, yours is at 0. Zoom, I guess we can leave it the way it is.
I think, our target distance needs to get
bigger.
Yeah, much bigger because I think we're so.
Yeah, because
I'm only got yellow screen. It says I gotta.
Yeah. The
Um,
fuck happened? My shit just turned yellow, man.
yeah, because the distance isn't
Target
okay.
distance.
At 10,000, you can see the grid and everything. So maybe if
Okay,
we want to go a lot further,
10,000.
maybe hang on, let's try 30. I mean, 30,000 is more of it easier to understand what we're looking at.
Okay, perfect.
Yeah,
Yeah.
so 30.
So 10 observer height, 30,000 distance, target size, what, 100 meters is fine.
Yeah.
Okay. Where is the figure we're looking for? Man, but this is gonna. I mean,
Okay, I see. So at the
cause,
bottom
cause, yeah, cause,
is what we want. Okay.
yeah.
So basically,
But
it's going to show. So the one that would show the distance from eye, it'd be the distance on surface and distance from eye would have to be the same for to make what you're saying correct.
what's yours?
My distance on surface is 11,288 meters, and my
Uh huh.
distance from eye is 11,288.1. And
What?
then just
That is the weirdest shit. All right,
and
we
then to
basically
and then and
have
then
the
to
same numbers except that point one. What?
so you
Yeah,
because
but it's the same,
that's
Sean.
but it's not the same. It's not an accurate location. It's still it's still off.
All right, I'm gonna take a
And, and,
screenshot and post
and
my
again,
results.
remember how we were how the golden rule of the 8 inches squared per mile is that the offsets will change. The offsets change it. What do you think's happening right now? The further out we go, the bigger that number is going to get for us.
Yes, true. All right, so that's what I have.
Okay, I see. I see.
I mean, what do you have?
Look on you know.
Why though? Just because of refraction? No way.
Oh, this is. Hang on, look this out.
No,
So
no. There's no way this is just being caused by refraction. Like that
yeah,
difference is
I'm gonna
too
show you
much.
right now. Show you right now. Look.
Yeah.
So oh, perfect. So if you look at that picture, it shows you the geometric horizon and the horizon due to refraction, and everything changes. I mean, it even shows you where the parent point is. And that difference throws everything off. That's why you can't use 8 inches square per mile to measure the Earth because of that image you're looking at right now. Yeah, that picture alone that shows exact. I wish I would have seen this picture before because that picture we're looking at, that picture explains everything I'm trying to explain.
Very interesting, Sean.
Because I get what you're saying, and it seems logical in the sense of I'm standing here, That's a location. The problem is it's like you were saying, man. We always look through a miraging, refraction. It's an illusion. That horizon is not the horizon. Even or I'm sorry, it's not the horizon, the real horizon when we're looking at it, because it's not always there. It's not always what everyone sees. It's it was a mind blowing experience when I realized why it's called the apparent horizon so much. I didn't even know the geometric horizon was actually not something. It wasn't even real world. You can't use it in an observation because it's not the same.
Yeah, I still need to look into this, but I get what you're saying though. Yeah, obviously looming is happening.
Mhm.
Or whatever it is we're looking at is being pushed up higher
Yeah,
and further.
we always have to assume there's refraction. Like you said, man, even between our screen and our screen and our face, there
No,
is
but hang on,
refraction.
man.
It's
No,
not
no, but this is the distance to the horizon, right? Isn't it we're worried about the distance to the target, to the
okay.
building itself?
Here's
Because
the
obviously
problem.
my horizon is being loomed,
Okay,
but
but
the
if
object
but
itself.
here's the thing. If we
Mm-hmm.
can both see the physical object, not the mirage, the object, no matter where we stand, that object stays the same. We've already established that.
Then I'm kind of lost as to okay. Yeah, but
You, the horizon,
okay.
the horizon never is in the same spot, whereas a fixed location is always in its location. A boat, if you froze time and we're looking at a boat, that boat is there. But if you remember, general relativity, special relativity explains why it's not physical, because everything has to be done with two observers. Otherwise, it doesn't. You can't explain it through one observation. You need two observations, two perspectives to pinpoint it, basically. And
Yeah.
the funny part is that the reason this all happens is exactly what you were saying, refraction. The reason where this conversation is being had is because refraction does not give you the correct vision. The same way we don't see the sun at its point. We see the sun 8 minutes and 20 seconds after it started its shine to us at that moment. It's always behind. It's never in its exact spot. It's always in its apparent spot.
I hear you, man. I just all right. I need to go back and look into this. I ain't
Hmm?
conceding shit, but you do have a point.
I see. Yeah, no,
You
no,
do have a
yeah, no,
point,
yeah.
but I need to to write down the points where
Mhm.
that I had and we're arguing for because I've kind of
Yeah.
forgotten
No, 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 no worries.
what I was saying initially. But
Mhm.
yeah, you do have a yeah. Okay, yeah, true. Horizon, the horizon and everything is fucked up by refraction. I just need to remember the point and idea I had in my head.
No, no
Cause
worries. It was
yeah,
this was a spontaneous conversation. It's not like you were prepared. Not like anyone was prepared. I've
yeah.
had this conversation so many times. I'm always ready. But it was like out of nowhere. I kind of just said, "Hey, you're wrong." So no. Give me time. It's all good. I get it. It's cool. I mean, no matter
All right,
how
all
much
right.
research you do, I'm gonna be right. It's how it works.
Okay, okay. No, no. But listen. Give me like an hour to 2 hours,
Yeah,
and
yeah,
then I'm gonna tag you. All right.
yeah. No worries.
All right. Cool. You want to go back to Jose's?
Yeah, yeah. I'm gonna go over there and listen.
All right. Cool, man.
All right, man.
Easy.
Good
All
talk though.
right.